Let's work on correcting errors together that may come up when you're practicing writing functions. So this is a fun example using time dilation. Find the link, go to File, save a copy in Drive, and then let's just talk about it for a minute. So time dilation is basically Einstein's theory of relativity as it relates to time. The idea here is that v, as stated underneath, is someone's velocity, c is the speed of light, t is the amount of time that has passed for that person, and t prime is the amount of time that has elapsed by comparison in the non-moving reference frame. You can imagine it as, say, Earth. Okay, imagine that one person is on Earth, and then someone goes away at a certain speed and will return later. Now, I would say when you've copied this, go ahead and get rid of the copy, or not the copy, but the mention of copy in the title, and then go to runtime run all, because even though like it's copying over, you're losing the benefit of sort of collab errors that would show up if you were sort of if the code was your own. And what I mean by that is like the underlines. So if I find that the underlines to be helpful in this current era of collab notebooks. So I can tell you that to simplify this a little bit, the math here is basically correct. Okay, so it's not like some mathematical nuances. That's not where the errors are. And so you can see there's a lot of underlining going on. There's a syntax there underneath with an arrow. And what you need to do whenever you get errors, I would say the first thing is to look at it and see if you can catch them just by sight. Okay? If that's too difficult, you can go back and look at previous code, certainly. That can help. And then you can also go in here and look at what it's pointing at. So it's pointing at the D dilation. And so if you can catch it, the reason why that's invalid syntax is because when you write, like if you write the word time with a space and there's been no reference to time, Python is expecting, it doesn't really know what to do. It's like maybe looking for an equal sign. To join time and dilation in one word, you need the underscore. Okay, so that helps. Okay, additionally, you need the keyword def every time you start a function. And so that looks good now. The first line has been cleared, but the next line is not. And you could always try to run it and see. And look at this. Sometimes these collab, error hints are very helpful. It says expected a colon. Okay, and it's giving you a carrot of where it should actually be. So that's really nice. Colon does need to be there. So go ahead and put it there, run it again. And then we get indentation error, expected an indented block. So once again, what we're finding is that reading some of these errors can be helpful. Return is not indented. In order to always make sure I get the spacing right, I just go to where it is, backspace it to the previous line, then press the return key, and now it's in the right space. Now let's continue with these underlines. V and C are underlined. So what should that clue you in at? They haven't been defined, right? Like time is time, V and velocity, those are different. And so I think VEL is nice. And then C here is underlined because it's also not been defined. Now C is the speed of light. It can be helpful to define that even outside of the function. C equals, and it's 3 if you're using meters per second, 3 times 10 to the 8th meters per second. Okay, so that's defining C. A note here could also be helpful if you're returning this in. Define C as speed of light. Okay, not essential, but helpful. And now it's looking much better, right? We're not seeing any underlines. So let's check it. Okay, and it got through without any errors. Now let's check the calling of it. See, does that work? No, it doesn't. It says name dilation is not defined. Okay, so when you're changing the name of your function and then you're saving that change, you've got to follow up with the change here. Okay, like maybe one time you did it with like that and that would be valid, but now we need the underscore. Okay, so we have the underscore. Let's try it again. And we have a result. Okay, so what this is basically saying is that if you fly away in a spaceship for a year at 10 meters per second, which I don't think is possible, the time on Earth is going to be a lot less. Well, what if it's 100 meters per second? That's a little more plausible. Okay, it's hardly anything. So how can you get this to be interesting? Well, how close are you to the speed of light? Are you at 10% of the speed of light? Okay, that would be extraordinary. I don't think we can do that yet. But what if you were? Well, now it's still just a year, but it's like, okay, it's like a little more than a year has passed on Earth. What if you're at half of the speed of light? Ooh, now like, okay, there's some extra months and maybe you don't notice it. But what if you went at 90% of the speed of light? Wow, like the years have changed. You come back and you're like, wow, you look much older than I expected. So what if you're at like 99% of the speed of light? Ooh, 7 years. What if you're 99.9% of the speed of light? And I'm just showing you this because it's fun. Like this is actual code, this actual theory of Einstein's relativity. It's one of my favorite things, honestly, about programming is that you can come across definitions, mathematical, in this case, it's physics definitions like about cool things like time dilation. And this is a great way to play around with them. Note that this is much more efficient doing it like this than it would be with a calculator. So cool example. Hope you enjoyed it.